Hello guys, this is Karthik. Hope everybody are good. So today's topic that I'm going to talk about is two main things. One is an AI tool which is Copilot Pro, and the other topic is basics of classification. We'll go over why Copilot Pro is useful and how it can improve your performance and how it can give you an idea about coding in the software field. And the other thing we can discuss about basics of classification using an example of cat and dog image classification, where it takes an image and it will give as the classified label whether it's dog or a cat. So we'll see that. Introduction to the Copilot Pro. Let's start with why we have to or why we need Copilot Pro when there are many powerful AI models available today like ChatGPT, Claude, Gemini, DeepSeek, Grok, or Meta AI. The simple reason is that Copilot Pro stands out because it is built specifically for real day-to-day coding inside your development environment. And what do I mean by that? Meanwhile, other AI models are standalone used in standalone application, or you might be using it in web-based application to prompt and get the answers from. Whereas Copilot Pro is used by adding a plugin into your development environment IDE, which is IDE, integrated development environment, where you code your entire project. So instead of uh, copying and prompting from the online resource and pasting it and then getting confused where and what to do, you would simply use Copilot Pro inside your IDE itself. By getting access for Copilot Pro, you can use the prompt in your IDE itself by adding the plugin, which I've already mentioned, and hence making it stand out from other AI models or standalone applications. And Copilot Pro was built specifically for coding environment itself, which makes a lot of software industry people very helpful because sometimes people get stuck on some functions, some problems, from issues because they are struggling to know what kind of function that they don't know if it exists or not is available to them or not. Hence, whenever you give prompt to Copilot Pro in your IDE to read your whole file, whether it's Python, whether it's Java, regardless of whatever the language is, it will suggest you what kind of things that you need to use to make it work. Hence, making it uh, a plus for using Copilot Pro over other AI models. And when it comes to Copilot Pro getting access, you get a lot of AI models included inside the Copilot Pro. All these ChatGPT and Claude or Gemini, those things are already a part of Copilot Pro, which is why it has different categories, different models to choose while you're receiving the prompt. And since lot of programmers and real world software industry use Copilot Pro for their day-to-day life, for coding, for getting help. The model is trained so well that it will easily give you what you are looking for, especially when it comes to coding. So hence making Copilot Pro the best among any of the standalone or web-based application. And for students, we have the offer here. So what I've discovered is that for students, there is something known as a student developer pack. With the help of it, you can gain an access for the the period of your bachelor's or master's, the studying period. So you can get an access, free access, and make utilize of Copilot Pro for your studies or for the projects, where you can understand how to write code, how to write it efficiently by not only copying or giving it prompt, but also understanding how professionally it could be written rather than just try. It saves a lot of time because it's directly integrated with your IDE, making it best and stand out from other options. So, this is how it is used by adding the plugin if you are using VS Code, and if you are using other IDEs such as JetBrains, IntelliJ for Java or C Sharp, and so on. So they have their own plugins for Copilot Pro, integrating Copilot Pro, and you can log in your account there and make use of it directly into your coding environment. Start with classification now. So we'll understand basic idea of classification and where it falls. So classification is a part of machine learning, and machine learning is a part of overall AI. So we use classification for organizing the data, objects, or information into predefined categories or classes based on some characteristics. So just like how you group specific uh, people or specific objects and name it or label it. So that's what it means when you talk about classification, to classify it to this group. So each items is assigned a label from fixed set of label. Okay. The goal of classification is to make data easier to understand and analyze. When you classify, it's obvious that you can know that it shares similar characteristics, similar properties, we can say, which will be useful for making decisions for later analysis of data. Uh, this categorizing will help. So, why classification is used? Classification is used to identify patterns for predicting the outcomes, just as we discussed about what is classification. We already clarified why uh, classification is used, which is to identify patterns, to group them, find the pattern and group them so that we can predict the outcome from the specific classes. So, why is it important? Classification. Classification is important because it helps in structured data analysis. It is efficient and it efficiently retrieves the information. As the grouping is already done, if you are searching for something, uh, for example, in the code, if the code is searching something from a very big data set, uh, the information retrieval happen from the categories which is close to what it is expecting the output. So many real world systems like email spam filter and medical diagnosis tools, recommendation system depend on this classification itself. So classification in machine learning, it is a supervised learning technique. And we have this term supervised and unsupervised when we are talking about AI and machine learning. So supervised is nothing but it learns from the labeled data. The model will learn from the labeled data. So the model knows what are the categories and what are its label, what class does it belong to. So models are trained with this supervised labels. So unsupervised is nothing but the classes which does not use any labels. So it doesn't have more information about the data when it comes to unsupervised. So what are the key features of this classification which we already talked? That is labeled data, and it predicts the discrete categories and based on patterns and features. And importance of the classification we already know. So helps in decision making and reduces the time. That is the main point, which makes the code efficient because when it is classified into a specific categories, the fetching of that information becomes uh, very less when you compare it in time based. So improves speed and accuracy, handles large data set efficiently, which is same as reduces manual work. All these things are the main pillars of classification, why it's important. And real world example, let's say email spam detection. So emails are classified into spam and not spam, right? So system learns from the past emails which are already classified in if it is spam or not spam using specific keywords. The features includes keywords or who the sender is or the links which it came from. So detecting all these keywords, senders, and links, the text, right? So it will classify and divide them and label it as spam or not spam. It will help users to avoid unwanted emails. Without wasting any further time, we'll get into our classification. So we are using image classification here. So image classification is a type of classification where the input is an image and the output is label describing the image. So we are going to pass the image as an input for our model, and that will give an output of label, like what category does it falls under, whether it's dog or whether it's cat. So we are going to understand line by line what are the things that we used here and what it does. Okay, so the very first line, it says import sys, that is we are using inbuilt system library to get access to the command line argument, because we have to pass the image path into the model. So we need command line to take an argument and pass it into the functions that we use in the code. So then the next line is importing path from path library. What is path lib? It handles the file path in a clean cross-platform way, used to check if the image file exists or not. It's all about path. So the next line is torch. So what is torch? It is a part of PyTorch. So purpose of PyTorch is its core deep learning framework. It handles tensors, neural networks, GPU support, etc. Used here in this code for running the pre-trained model. Okay. Then next comes torch vision. So we are importing two things from torch vision, that is models and transform. So purpose of models is it provides pre-trained neural networks like ResNet. And take a note that we are using ResNet here in the classification. And ResNet is a neural network with 18 layers that learns visual features from images. It has pre-trained weights as well. So we are not going to build everything from the scratch to label or add weights. So we are using ResNet 18 for this process. 18 layer is nothing but it's a neural network which consists of 18 layer of passing these images. So all the features of the images, it will be passed to this 18 layer for clarification or classification. So now the next line, that is from PIL import image. So PIL is a part of Python itself. So Python image library it's called. So we are using that because to load and process the image files, to convert image into a format that PyTorch can understand. Okay. So the next line is about the whole function. So in Python we use def for defining, or definition or function we can call, for writing the function. So before that we'll go to the main method or main function, so we can get to know whether the order is proper or not. So initially the system argument sys.arg means system argument, if it is not equal to 2, means like if it is equals to 1, then that means it takes. If it's not equals to 2, only then this statement get executed. That is basically giving the path of the image. It takes it from the user, and then once the path is pasted, then it goes to next line, which is image path. We are storing path uh, of whatever we got from here into this image path, and it checks whether image exists or not. If it not exist, then the output will be like this print statement, which prints input image not found at image path. And if else, then the next functions or next code of line runs. That is, load image is our function in our classification model, which will pass our image first. Okay, our image is passed, so we'll go back to our function there where we used load image, and it passes the image path, which means we are basically passing that image into this, and this is the function. So it processes. So these are the sort of processing for the RESTnet 18 library which we are using. To get it into that format using this function. So what it does is that it processes the image which we have passed to 256, which is recommended by REST, and also height and 220, 24, height and weight, width and height. So then it will transform it into tensors. Tensors are nothing but it's like for making a grid like or arrays like or vector like structure. So then the other function is that it normalizes. So wherever the critical stages are there, like wherever the image distortion or image has noisy data, it will smooth it out. That is why we use normalization by using mean and standard deviation. So then that is a function inside our function, so that now the actual function is getting executed on this line, image line. So image equals to image.open. So image path. So whatever we have passed the image, that will be first opened and converted into RGB format. So RGB format it will be converted, and that converted image is passed into the main function, which is preprocess. So that image goes inside the image, and then this preprocess will transform that picture into the format that ResNet 18 needs. Okay. So now let's go to other functions. So this is our main function or main class. We made it a class because it could be reusable in the future, or we can say it's reusable block of code. So we have pre-trained models in prediction logic, and since to make the code clean and reusable, we used class. So model initialization is when it starts. So we are loading the models of ResNet 18 in this function, because we need all these three lines of code to get started with the model. Here in this third line, as you can see, cat talk indices. This is pre-trained weights that are available in ResNet 18 already. So we are taking these weights, which defines which category of dogs or cats. So for example, from 281 to 285, it's different cat breeds, and 207 to 208, it's dog breeds. So that's why we are taking that cat and dog indices, which is gotten from the ResNet 18. Now coming to next function, which is predict function. So we'll go by line by line. So this code defines a function named predict that takes the image, which is already converted into tensor, and predicts whether the image contains the cat or dog using trained deep learning model. Okay. So the first line defines or tells PyTorch that we are only doing this prediction, not the training, because training part is skipped, because as I mentioned in the earlier, this was not about doing everything from the scratch, but doing it with the help of predefined weights which are given by the ResNet 18 itself. So this means the model will not calculate gradients, which makes the prediction faster and uses less memory as well. So the next line goes to logits. So in this, the image tensor is passed for the actual model. So image tensor into the neural network model. So the model outputs the logits, which are raw numerical scores for each possible class. These values are not possibilities yet. Note that. So then it is uh, passed into the next function, which is the torch.nn.functional.softmax. Softmax is applied to the logits, which means softmax converts the raw scores into possibilities. Now, where all the values lie between zeros and one, and their sums equals to one, which means each probability represents how confident the model is about the class. Okay, so then we use the function probability.argmax. So this finds the index of the class with the highest probability. Okay, this here finds the index represents the which represents the predicted class label. The index is converted to an integer using int. Then it is finally passed into this set of indices. The function checks whether the predictor class's indexes belongs to the predefined set of indices, which we've already talked about. So to 281 to 282 and 283, 284 and 285, which belongs to the cat class. So these indices correspond to the cat classes. If the index is in this set, the function returns cat. Otherwise, it returns dog. So we got the label this last line after passing the image from the process, pre-processing, and finally we'll get the output as whether the past image is class of cat or dog. So that's it for the classification of cat and dogs. So this is how we can make use of classification. In real worlds, there are, as we discussed in the earlier, in real world, it could be not only used for the classification of image of cats and all, but also humans, traffic, or email spam or fraud detection. So these type of different applications are there in the real world where we can uh, implement the classification. So that's it for now. So thank you for staying with me, for whoever watching. So thank you so much.